So we're going to look at perimeter and area relationships and some certain concepts that come up when we're working with them. Oftentimes things we want to do is look at like what's the maximum area we can get with the least amount of material, or what's the least amount of material we can use to enclose something with the maximum area. So we're maximizing area, minimizing perimeter. So let's just look at these examples here of what I got working. Given 12 tiles, so I got these little squares, tiles here that I drew out. We can make the following rectangles. I can make a 1 by 12 rectangle. I can make a 2 by 6 rectangle. I can make a 3 by 4 rectangle. And that's going to be it. Because those are all the factors of 12. And the area will be based on the factors. Given the square tiles. If I was working with just a length of a certain length, then yeah, maybe I can do something different. But in this case, because we're working with these individual pieces that have a certain size, we can't reform in squares. So those are my different areas. I got 1 by 12. I got 2 by 6. I got 3 by 4. Now, given 16 tiles, we can make these rectangles. We can make this giant 1 by 16. I can make a 2 by 8. And I can make a 4 by 4 square. Keep that in mind. The square is important. So let's use those to fill in this table. It sets the table here. So if the length is 1 with the 12 squares, the width would be 12. The perimeter of that is 1 plus 12 times 2, which is 13 times 2, which is 26. The area is 12. And I'm not putting the units in because I didn't really write units, and I don't really have room to fit square in there. But normally we should be using units. The next one, anyways, is a 2 by 6. So the perimeter of that one is 2 plus 6 times 2, which is going to be 16. The area is going to be 12. And in the next one, the length is 3 and the width is 4. 3 plus 4 times 2 is going to give us our perimeter. 3 plus 4 is 7 times 2 is 14. It's an area of 12. It makes sense that the areas are all the same because area, again, is the number of squares that make up the shape. Well, because we had the same number, 12 squares, every time we should have an area of 12. The perimeter changes, though, because more sides are touching each other. If we do the 16 squares, we're going to get 1 by 16, 2 by 8, and the 4 by 4. Again, our area, I'm going to cheat. Our areas are all going to be 16 because we had 16 squares, but our perimeters are going to change. Perimeter of 1 by 16 is 34. Perimeter of 2 by 8 is going to be 32. Sorry. 2 by 8 is going to be 20. 2 plus 8 is 10 times 2 is 20. I don't know what I was doing there. And then the last one is 4 by 4. Well, that's going to be a perimeter of 16. Now, when is the perimeter minimized? When do we get the lowest perimeter? We get the lowest perimeter when we approach the shape of a square. So as this gets closer to a square, the perimeter decreases. As this gets closer to a square, the perimeter decreases. So the closer a rectangle comes to a square, the smaller the perimeter becomes, and I guess the last part doesn't fit. Let's cut that last part out. Just cut it right out. Gone. I don't like that. I was thinking of something different. So the closer the rectangle comes to a square, the smaller the perimeter becomes. If you're given a fixed perimeter, so if the perimeter doesn't change, so in this case here, our perimeter changed and our area stayed the same, but the square gave us the smallest perimeter. If you're given a fixed perimeter, so your perimeter has to stay the same, then what will happen is the square will maximize the area. And given a fixed area, a square will minimize the perimeter. Okay, so this is the one we looked at. This is the one we looked at. We didn't look at this one. Probably should have. My mistake. I meant to do that. I think I meant to do that 16 differently. Anyways, things to know. Given a fixed perimeter, a square will maximize area and minimize, and given a fixed area, a square will minimize perimeter. So what does that all mean? Well, find the maximum area given the following perimeters of rectangles. So here's some perimeters. 20, 36, and 50. Say you're trying to enclose an area. You got 20 meters of rope or something. Maybe you're making a parking area for a concert outside and in a field, and you got like 20 meters of rope, 36 meters of rope, 50 meters of rope. What's the biggest area that you can make? What's the biggest space you can make with that rope? Well, it approaches a square. A square has 4 equal sides. So what we need to do is divide by 4. 20 divided by 4 is equal to 5 meters. So 5 meters will be the sides. The area will be 5 squared, or 25 meters. Try any other dimensions, you will not get anything better. 10 by, what would it be? 5 by 5. Wait, we just did 5 by 5. 4 by 6. 4 times 6 is 24. 3 by 7. 3 times 7 is 21. You're not going to get it. The square is going to give us your biggest area. Same thing on the next one. 36 meters. We would divide 36 by 4. That's going to equal 9 meters. 9 meters. That'll give us an area of 9 squared, or 81 meters. In the case of 50 meters of rope, 50 divided by 4, well, that's going to give us a decimal. And we're going to get 12.5. And the area is going to be 12.5 squared, which is going to give us 156.25 meters squared. And that last one should have been squared too, sorry. So meters squared, all of them should be meters squared for the area. So there's our areas. How do you find the maximum area given a perimeter? Divide it by 4, and that will be the side length, and then you just square that to get the area. If you're given some areas and you want to minimize the perimeter, find the minimum perimeter. So here we have an area of 25. What would the side length be? Well, the area is something squared, so to reverse a square, we do the square root. Square root of 25 is equal to 5. So the side length is 5. Perimeter equals 2 times, 4 times 5, right? Because there's 4 sides and they're each 5. So the perimeter is 20 meters. And that makes sense because 25 meters squared, that was our maximum area from the previous one, and we had a perimeter of 25. 30 meters squared. Well, same thing. Square root of 30, and that's going to give us 5.3 or something like that. Let me take a look here. 5.47, 5.48. 5.48. And so we just multiply that by 4. So the perimeter equals 4 times 5.48, which is going to equal 21.91-ish meters. Okay. So what we've done there, we've maximized the area by dividing the perimeter by 4. We've maximized the perimeter, or minimized the perimeter by dividing, or square rooting the area. And now, taking a look when we're working and stuck with some fixed pieces. Sometimes we're working with sides that are fixed. So last one we were working with some rope and we could just move it around, things like that. But there's times where you're going to work with pieces that are fixed in size. Maybe you have sections of fencing that are pre-made and they're that length. If you're using some of those concrete dividers that they use on, you might see them on highways and things like that, and construction sites. Those are a fixed size. You can't work around that. You can't just chop them in half. It doesn't work like that. So we need to work with those. So if you're given, say, 20 sections of 2-meter long fencing, determine the dimensions of the largest area it can enclose. Well, 20 sections is where we want to focus here. The area will be a square made up of 20 pieces. So what we do is take our 20 sections, divide by 4. That's going to give us 5. So each side of our area is going to be made up of 5 sections. 1, 2, 3, 4, 5. So we're going to have these little 5 sections here. But each of these sections is going to be 2 meters long. So 5 sections per side is what we get. But 5 times 2 meters is going to give us 10 meters per side. So each of these sides is going to be 10 meters. So what's the area can enclose? Well, area equals 10 squared, or area equals 100 meters squared. So this will be able to enclose an area of 100 meters squared. Now, that was nice. 20 divided nicely by 4. Here's a problem. 18 sections of fence will mess things up. Because 18, we can't just divide 18 by 4 and get a decimal. 18 does not evenly divide by 4. So when we divide 18 by 4, what we're going to get is 4.5. What that means is one side will have to be longer than the other. So let's round up and down. So if we round up to these sides being 5, then these sides would have to be 4. Okay. So you're either going to get an even number, or like an integer here, or you're going to get a decimal of 0.5. Or 0.25, and it's really going to mess things up. But in most cases, you'll get something like this. And so one side is going to have to be longer than the other. So here we have 5 by 4. That's the best we can do. So we do 5 times 4 for our area. So our side lengths are going to be 5 times 2, which is 10. And that was in, we were in meters. Meters, and 4 times 2, which is going to give us 8 meters. So our area is going to be 10 times 8, or 80 meters squared. Now, if we did get something like 19 pieces, 19 is not going to break down evenly. So we're actually only going to get the 5 by 4 unless we don't make a square. We'd have to make a trapezoid and add 1 to one of the sides, and it'd be just a messy situation. And probably not good for many applications. So we generally will be working with even numbers when we're working with sections. All right, last bit. Sometimes we're working with an already finished side. Maybe we're gonna build a fence off the wall. You're gonna build a fence off the back wall of your house, so you'll have only 3 sides to fill. So here we're doing some rope fencing. So we got some rope. We're gonna go around. And we're building it off a wall. Maybe there's a building over here, and they're just kind of roping off an area at the back. Or maybe this is a beach and they're roping off the area that you can swim in. So they don't need rope along the beach. They just need rope along the 3 sides in the water. How are we going to get the area to find the maximum area? Well, each side is going to be the same because we're looking for a square. So we just divide 24 by 3, the 3 sides we need. 24 divided by 3, which is going to give us 8. So each side is going to be 8 meters. And so the dimensions of this are going to be 8 meters by 8 meters for the dimensions. If you had 2 sides filled in, maybe you got a situation where you kind of have this building like this and you're building the fence right here, you divide by 2. If you're dividing by 1, well, you're kind of stuck. You wouldn't really need to do much calculation there. But 2 sides filled in, divide by 2. 3 sides, divide by 3. If you need all 4 sides of the fencing, divide by 4. And that is our work with some perimeter and area relationships. So again, a square maximizes area and minimizes perimeter given the other value being fixed.